Now give me a smile. Go to sleep.
There we go. Now your teeth should be as good as new. You were on a bit of anesthesia, so it's understandable if your head hurts a bit today. Would you like to take a look at your perfect teeth?
Absolute perfection. Dentissimo. Dentist bookings simplified.
Hi and welcome everyone to Team 13's Distributed Systems presentation. Today we will go over our project in detail. We'll start off by explaining our general architecture with our 5 components. These components include our booking, REST API, clinic registry, local infrastructure, and our front end.
Now bookings.
This booking component contains the logic which handles the booking of an appointment, and it receives the appointment information through MQTT messages, subscribes to the topic, and then handles the information accordingly to create the booking appointment for the user. The booking component also contains a circuit breaker which wraps around the booking controller that handles all the logic, and then the circuit breaker has a threshold of 3 requests within 5 seconds. Once open, it takes 10 seconds to recover and close the circuit. The number of requests is tracked via a rate limiter which invokes the circuit breaker once the threshold is exceeded.
Now the REST API.
The REST API component receives HTTP messages related to either bookings or clinics, and if it is a request to get information from the database, it makes a direct call to the database and returns the requested information. If the request is to add or change anything in the database, it instead translates the request to the proper format and sends it to the MQTT broker for further processing by other components.
Now the clinic registry.
The clinic registry component is responsible for retrieving and storing clinic data, as well as ensuring that the clinic data being used is up to date with the provided online dentist registry. This is done on a scheduled basis in an automated manner.
Now the local infrastructure.
We use Docker alongside Docker Compose to run our local infrastructure. The infrastructure is defined as a Docker Compose configuration file, which is used to create containers for different dependencies, such as MongoDB and MQTT.
Now the front end.
Now, about the frontend. The frontend is the component that uses all our other components to create a visual layer for the user. In our case, the frontend receives information from the REST API, which in turn retrieves data from the associated components, which are the clinic registry and the booking component. With the help of the REST API, we can allow users of our app to book and view dentist appointments, view clinics on the map, and receive directions to clinics.
Now I'll talk about the design decisions that affected our final design. There are 2 main design decisions we made. The first one was to use a monolithic database model rather than a microservice. And our reasoning for this was that using a microservice design, we would not need to constantly update the associated databases to ensure that the data is correct throughout. Rather, everything is stored in one place. Our other main design decision was to ensure that the clinic bookings are created automatically by the booking component. Therefore, no manual creation of bookings through Postman is needed. And this design decision resulted in more logic needed for the booking component and the REST API, respectively.
Now the architectural styles.
In this project, we used 4 different architectural styles, and the first one is Publish and Subscribe. Publish and Subscribe is used to enable components to communicate with each other in a manner that ensures distributed transparency. It also allows us to design our system in an event-driven manner. For example, if a user makes a booking, we consider that to be an event. The second one we chose to use is Client and Server. The Client and Server architectural style is used within our components to communicate between our front-end web page and back-end server. The communication between the components is done by the broker, and the client uses a RESTful API. The third one is microservices. So the microservices architecture style is used to ensure a decoupled system. This is done by having a collection of independent components with a shared memory communicated through messages. In addition, this assists with scalability since new components would not interfere with other components and functions independently. Lastly, we use pipe and filter. The pipe and filter architecture was used in combination with the pub sub architecture. We used this design decision to incorporate one-way processing in the system. The filter takes place in the booking component to filter out the unnecessary information that is not needed for the logic inside the booking component.
Now we'll go over the component diagram in more detail.
The booking component is used to deal with customer bookings. It is designed as a service running on top of an express HTTP server that continuously listens to messages from an MQTT broker. The component processes all messages by either discarding them if they are not correct, or by persisting the received data as booking information to a MongoDB database.
Regarding the circuit breaker of the component diagram functionality, once a request is received, the circuit breaker wraps around the booking handler in terms of first passing the booking request to a request limiter, which checks if the threshold of 3 requests within 5 seconds is broken. If the threshold is broken, the request limiter invokes the circuit breaker to break the circuit. When the circuit is opened or closed, this will be published to the broker. After this process, the circuit breaker then allows for the booking request to be handled by the booking handler. The REST API booking controller has a subscription to an MQTT channel that provides the status of the circuit breaker. If the circuit is open, the REST API will not publish booking requests to the broker and instead will send a 503 status and message back to the client.
The REST API component acts as a single point of entry to the backend of our system. It is designed as a service running on top of an express HTTP server that exposes multiple REST endpoints. The service is connected to an MQTT broker to distribute actions from the REST API to the rest of the system. It is also connected to a MongoDB database to directly retrieve clinic and booking information when GET requests are received.
The clinic registry component functions as follows. The registry reader retrieves the provided online registry data. This data is then passed to a JSON comparator. The DB collection retriever retrieves any existing registry data that may already be stored in the database. This data is then also passed to the JSON comparator. The JSON comparator then compares data from these two sources. If there's a difference, the DB updater will be invoked to update the shared MongoDB database. This happens in a scheduled and autonomous manner.
The frontend component has 4 main functionalities. A clinic map, a clinic search, a way to get directions to a clinic, and to book dentist appointments. The clinic frontend data is retrieved from the clinic registry through a REST API request. Similar, the booking data is retrieved from the booking component via the REST API. The map instance uses Google Maps JavaScript API, while the clinic directions use Google Places and Directions API. Here's the component diagram as a whole.
Now I'll go over the booking transaction. So upon entering our app, you're greeted with a home page. Here there has basic information about our app and also wants to guide the user to the map or else to use the search by clinic. In searching by clinic, you are then able to enter a specific clinic. But in our case now for this demonstration, we're going to enter the map. Upon entering the map, the user is greeted with the associated clinics, where they can, based on clicking on them, see the associated information. I see the Crown, your dentist, the Severus dentist, or Tooth Fairy dentist. Let's say you want to go into the Tooth Fairy dentist. We're then able to go into the associated clinics, which you see is unique by the route identifier. And based on this, you are then able to see the available bookings and also book a time. And based on that, you can then confirm those bookings. And here on the bottom, you're also able to see the opening hours and the clinic location. Upon confirming the booking, the user will be directed to a confirmation booking screen where the clinic information is stored. And if we say that we were going to store this code, and we say we go back now, the user is then able to go to view booking details here and paste this code. And upon searching, the user will be taken back to that screen so they can see their confirmed booking.
Circuit breaker demonstration.
The circuit breaker will now be demonstrated. The threshold of the breaker was made 3 requests within 5 seconds for demonstrative purposes. Once the circuit is open, it'll take 10 seconds before it closes again. I have here a few tabs open to demonstrate this. As can be seen, once 3 requests were made within 5 seconds, the circuit is opened and I cannot make any more requests. Any more requests will result in the same error message popping up. After the 10-second cooldown, I can then create a request successfully.
Regarding what quality of service that we're supposed to be using for the project, we agreed to use quality of service 1. This is to ensure that the message arrives at least once, and then there's the logic component that will ignore duplicate requests and it will handle it accordingly.
Individual contribution.
During the initial stages of the project, we decided that I should be responsible for the meetings, making sure that the meetings were taking place, and also to remind everyone what the meetings are. Another responsibility is that I had to roughly plan out the meetings so that the meetings were properly structured and to make sure that everything were going smoothly. In terms of actual development, most of my contribution lies in the booking component at the backend. I mainly worked on developing the logic that is behind the feature of booking an actual appointment. I also worked with MQTT to connect the REST API components to the booking component. I also did a pair programming with Mattias and Nils for the REST API and frontend, respectively.
The role I had in the team was of a developer. I worked mainly on the frontend for this project. I took part in making a search bar that retrieves clinics from the database, where users can find the clinics by typing a clinic's name. I also took part in modifying the navigation bar and making it responsive for different screen sizes. Then I created the homepage for the web application and made some changes to the bookings page. Finally, I made the layout of the page where users can see their booking details.
During the project I mainly worked on the front end. I created the search bar, homepage and the simple page that shows booking information. After that I also worked on the navigation bar, playing with the layout. And I also worked on the bookings page where I made some small adjustments.
First, I helped Albert when he ran into problems with the booking component or had questions. The major point being how to break apart and process the information it received from the MQTT broker. I then created our MQTT solution in the REST API component so that it could connect to the broker and send or receive data between itself and the broker. Finally, I created the booking endpoints in the REST API and the respective behaviors, which mainly consisted of translating the request to the correct format and publishing to the MQTT broker.
In terms of code, I mostly worked on the booking flow by adding persistence logic in the booking component, exposing booking operations in the REST API, and implementing parts of it in our front end. I've also set up our local infrastructure using Docker and Docker Compose. Alongside my code contributions, I've helped the team by reviewing merge requests and writing documentation to keep the team on the same page.
My contribution was mainly done on the front end, creating the map, clinic screen, front-end booking design, map directions, and navigation bar. Other than code, I took part in meetings, reviewed merge requests, and created this video.
Regarding the contributions of Younis Akel, I created the clinic registry component as well as a more detailed component diagram for it. I also added CI to the clinic registry repository that included a syntax checker. For the RESTful API, I created endpoints related to the retrieval of clinic data, as well as error handling middleware and specific loggers for development purposes. I also added the circuit breaker for booking requests. I would also update the component diagram with any changes or features I implemented. I also included an update log to the documentation for any changes I made to diagrams, added code comments explaining the why behind the code I added, and also reviewed merge requests and provided feedback, as well as creating user stories and tasks in Trello. I also added high-level code description to the clinic registry and booking component, and worked with the team on the initial documentation and finalization of the documentation. I would also contribute to all retrospective reports and partook in team meetings and TA meetings. Finally, I was responsible for keeping the Trello board up to date, as well as ensuring that it was organized accordingly.
We are Dentissimo!